So I guess good idea to get started on time. All right. So welcome everyone. It's a pleasure to have James Graham today with us. James is currently at the University of Sydney. He's a lecturer, if I'm wrong, or a senior lecturer.
Senior lecturer.
Senior lecturer at Sydney, and James completed his PhD in economics from New York University not so long ago, 2020. But even then, he has already established an excellent pipeline of publications. He has published in American Economic Journal Macroeconomics. He has published in Journal of Economic Dynamics and Control. And today, James will be talking about consumption behavior across the distribution of liquid assets. James, you have 1 hour and 15 minutes. It's up to you if you want to take questions on the go or you want to defer all of them towards.
Oh no, I definitely love to take questions throughout. So yeah, if anything's not clear or you want to tear me apart for something, happy to happy to go with that. So I don't know if you guys, I don't know if you put hands up or whatever. I can sort of see the screen, but it's off to the side. So maybe just unmute and jump in. That's probably the easiest thing to do.
Yeah, or I can interject and let you know that there's a hand up. James will be teaching shortly after this seminar, so he has requested that the seminar be contained to 1 hour and 15 minutes. But without further ado, James, the floor is yours.
Great, thank you. Yeah, and thanks all for having me. Nice to see some faces I've seen recently again. So this is a paper that I'm actually currently in the final sort of stages of revising for resubmission. So now's a really great time to get any comments on anything that's not clear or could be clarified a little bit more in the draft. So this is work that I did with a colleague from my grad school program. He's now moved into consulting, private sector. So it's mostly me working on the redrafting and everything. But yeah, I think this is a nice paper. So hopefully you guys are interested in it as well. So the motivation for this paper is to think about how consumers or households spend in response to income fluctuations. And obviously this is central to most of our macro models. We think of things like Euler equations as kind of driving a lot of aggregate fluctuations behavior. But from a microeconomic or theoretical perspective, a lot of this work goes back to Friedman's work on the permanent income hypothesis from at least the 1950s. So just as a reminder, this is a really simple model of household consumption smoothing behavior, where households are seeing income shocks come and hit them, and they're going to want to try and have their consumption fairly smooth as these shocks are buffeting their income around. So what we'd expect in that kind of model is that a household would receive some kind of income shock. They're going to, let's say it's a positive income shock, they would save a lot out of that positive income shock and then take the savings and spread them out as consumption across the remainder of their life. And of course, if they have a very long life left to live, this could mean very small pieces of consumption in every period going forward. But going back to at least the 1970s, many papers, a very large literature has pointed out that in the data, consumption is excessively sensitive to these income fluctuations relative to that permanent income hypothesis benchmark. So households do not smooth consumption particularly well. Instead, their consumption and their income are very strongly correlated through time. And I can go into a lot of detail about this, but there are papers doing this with aggregate data, with cross-sectional data, with panel data, and so on. And I think a trend here is that the data sets are becoming more and more detailed and more granular, and that's where we're going to go today. So just briefly on that. So what the theoretical literature has done in response to seeing this excessively sensitive consumption behavior is they've tried to introduce things like liquidity constraints as an explanation for why households might be having to adjust their consumption around a lot around the time of an income inflow. And so you might think that a household has exhausted all of their existing assets and then suddenly they're hit with maybe a negative or a positive income shock. If it was negative, they're just forced to cut back their consumption. But even if it's a positive shock, if the being at the liquidity constraint means that they were under consuming relative to the optimal choice of consumption, they may suddenly increase the consumption quite a lot in response to this incoming inflow. Now, the difficulty with this kind of theoretical literature is that it really only applies to some subset of households who have spent all their money and are very close to the maximum they could possibly borrow. Greg Kaplan's work on the wealthy hand-to-mouth suggests this might be something like 10 to 20% of the population. There might be another 10 to 20% of the population who are sort of wealthy hand-to-mouth, but for the most part, we're talking about less than half of people being likely to be near a liquidity constraint. But recent empirical evidence suggests that even very wealthy households, and here I mean liquid wealthy households, are also excessively sensitive to these income fluctuations. So I'm going to show you something on that too here today. Households with lots of resources available to them still spend as if they're, in some way constrained or look like they're kind of constrained. So let me just very briefly say what we're going to do in this paper. So the first thing we're going to do is revisit this evidence on excessive consumption sensitivity to income shocks. We're going to make use of a very rich micro data set to study these spending responses. So this is administrative data. It's a bank transactions data set. Our full sample is extremely large, something like 17 million households. We're not going to be able to make use of that many. It's just too large, but that's the extent of this thing. For these households, we're going to see daily frequency transactions. So things like their spending, their income inflows, but we're also going to see snapshots of their liquid wealth. And so we're going to be able to tell, are these households likely to be near a constraint, or are they in fact quite far away from a liquidity constraint? And then we're going to focus on one particular type of income inflow. We're going to call this anticipated income. These are income shocks where households almost certainly know the income is coming to them at some point in the future. They typically know the size of this income inflow. And then, we're going to see whether they respond to it or not. So the main exercise we'll do makes use of tax refunds. This is all data for the US, by the way. But we'll also look at things like bonus checks and regular paychecks. And what we're going to find is something quite similar to that figure on the bottom right there, which is that household consumption behavior is going to be very non-smooth. So let me explain in more detail what I mean. So along the bottom, the x-axis down here, you can see negative 30 up to 150. This is days until and days since an income inflow. So think of this as like a tax refund. So in the 30 days prior to a tax refund, you can see that the spending response is very, very close to zero. So households effectively are not spending out of an income inflow that they know is coming and that they know they will have access to very, very soon. But these households are not spending. So it suggests that households don't smooth consumption on the, like before an income inflow. Then in the days between receipt, which is at day 0, and then up to day 30, which is 1 month later, this is where households spend most of their money. So they get a tax refund of some dollar amount, and they're going to spend up to 20% of it or so in that first 30 days. But you can see in the following days, days 30 through 150, they're only spending another 10 or so percent. So it suggests that households spend about 70% of what they are going to spend within a month of receiving an income receipt. So this suggests that overall consumption is extremely lumpy. You do nothing ahead of an income receipt, you spend a lot on the days or weeks after an income receipt, and then you spend very little thereafter. This is very much in contrast with the standard permanent income hypothesis model, and I'll show you that in a little bit. Now, everything I'm showing you here is averages across all of the households in our data set, but we can also show, and I'll show you what this looks like for households across the distribution of liquid wealth. And we're going to show two things. First, these patterns of spending are exactly what you see right across the distribution of liquid wealth. So low wealth households are going to have that, no anticipated spending response and then sharp spending response thereafter, but so are high wealth households. And this is sort of surprising because we might expect that high wealth households, knowing that some income is about to come in, they could start spending out of that income today, and yet they don't. And high wealth households shouldn't have any need to spend lots of this money right away. They should be exactly the kinds of people who could spread this out over a much longer period, and yet they don't do that. The other thing we find that's very consistent with the rest of the literature is that the total size of the spending response, let's call this the marginal propensity to consume, that is declining with wealth. So low wealth households have very high spending responses. High wealth households have very low spending responses. However, they're not zero. So, and they're not small either. They're around, let's say, 10% after 30 days. So high wealth households are also very sensitive to income receipt. I see there's one hand up, Rodney.
Yeah, sorry. Sorry to interrupt, but
No, that's fine.
I want to know what liquid wealth actually means in your data. I mean, if you have data from just one financial institution, then basically that's data on their liquid deposits. But that's not an indication of their overall wealth, I wouldn't have thought, right? Many households have all kinds of other forms of wealth, right?
That's true. So I'm going to tell you exactly what we measure as liquid wealth soon, but loosely it is their deposit accounts, their transactions accounts, their savings accounts. But it also includes a few things that are slightly less liquid, like money market mutual funds, certificates of deposit, some other kinds of deposit accounts. It's not everything. I'm going to compare the data that we have to some nationally representative samples of liquid assets, and we do undercount liquid assets, especially at the top of the liquid wealth distribution. So we're especially undercounting the liquidity of the high liquid wealth guys. We look okay on the low liquid wealth guys, but of course they might be hiding cash under a mattress and stuff that we can't see either. So yeah, this is liquid assets at a particular financial institution. And that's the best we can sort of do.
Yeah, I mean, the danger is that you may have some relatively poor people who have very high levels of liquid asset for various other reasons, but have no, no stocks, shares. They don't own their house, all of that. So you have no way of telling just what level of wealth security they have that could be also driving their consumption behavior.
That's right. However, we don't think it's a problem for comparing. Okay, we don't think it's a problem for the finding that this pattern, the shape of spending, just exists the entire way along the liquid wealth distribution. I think you're right that we might want to be careful about, let's say, the size of the MPCs, because perhaps we haven't sort of properly captured the full distribution of liquid assets. But the shape, I think, isn't a problem. The shape is just, you see it regardless of where they're sitting. So even if we're undercounting liquid wealth, it's sort of surprising that you would be seeing this, lack of anticipated spending and significant overspending in the first 30 days. But yeah, you're right. It's subject to these caveats, as every paper in this literature is. So
understood. Yeah. Thanks very much.
No, it's a good question, and you'll see exactly what I mean by liquid wealth quite soon. Yes. So this is the empirical part of our paper. And then what we're going to do is say, okay, can we do something to get these empirical results to look more like what a theoretical model might suggest? So the permanent income hypothesis is not going to work here. So the original model is that there's no such thing as liquidity constraints, everyone smooths consumption. That's clearly not consistent with the data. The modified model says, okay, take the permanent income hypothesis, but add some people who are liquidity constrained. That's also not going to capture the data here because these wealthy guys are also spending in odd sort of ways. So we're going to instead turn to the behavioral macro literature, and we're going to follow one paper by Sheffrin and Thaler, but this is Thaler made this work very popular, this mental accounts models of consumption behavior. So there's technical ways of describing this, but I'm going to give you a story instead. So I'm going to think of my mother when I was young. And so what she used to do is she would have these little envelopes with little words on them that might say, school uniforms or swimming lessons or, camp or something like that. And she'd stuff all these money into these envelopes as time went on. And the envelopes lived in the cupboard, and it didn't really matter what had happened in that week in terms of her income or unexpected expenses. She just really didn't want to touch those envelopes. They were put away for specific purposes. And that means the money in those envelopes is very different from the money that's sitting in her wallet. So the technical way of describing this is that there's a non-fungibility of income versus existing assets. Households don't want to treat $1 in the wallet as the same as $1 in their deposit account or their checking account. And what this is going to do is generate a form of dis-savings aversion. Households are not willing to dip into those envelopes. Instead, they'll just start spending out of an inflow as it comes in. So in the simple model to start with, we're able to derive analytical expressions for marginal propensities to consume. And they're consistent with this, zero anticipated response and the significant front loading of expenditure responses. But this model's not going to have anything to say about liquidity because it's otherwise going to look quite similar to the permanent income hypothesis model. So then we take those preferences and put them in a fully specified heterogeneous household model where we can capture the liquid wealth distribution. And we're going to show that this model does a fairly good job of capturing this kind of kinky consumption behavior, lack of spending up front, lots of spending after the money arrives in your account. And then I may not have time for this, but I'll just say it right now. We finally finished with just some very simple fiscal stimulus policies using that model. So we're going to think about targeted spending or targeted fiscal stimulus or untargeted fiscal stimulus. Targeting is when we say, let's give some money to the bottom of the income distribution or the bottom of the asset distribution, whereas untargeted stimulus is just giving everyone the same amount. And what we find is there's very little gain from targeting your stimulus spending, partly because high liquid wealth households are still spending a lot out of an inflow, which is not what you would see in a standard model, like a more, more PIH style model. I may not get time to show you this, though, so we'll see how we go. But anyway, that's the high level overview. Yeah, Gresh, how are you?
Quick question here, James. So, I completely understand your intuition here about non-fungibility of income, and that might as well be driving what you're talking about. But if I think about it, we can also think about this more simply and say, you talk about all households at the spectrum of liquidity and wealth. They all have this instant gratification of sorts, which basically in a model perspective would mean that you have a higher discount for future. And as a consequence, if you have even anticipated income, you will tend to spend more and nothing before that.
Are you just, I have a quick question about this, because we didn't go ahead and model this, but our view was that wouldn't account for this lack of anticipated spending, because I had thought that if you have something like Gullen-Pessendorfer's kind of temptation preferences, as soon as I let you know that you have future income, you should want to you'd be tempted to spend out of it. So I had thought you actually wouldn't get this kind of the lack of anticipated spend in that sort of model. But
that's
do correct me if you're wrong.
No, that's a good point. That's a good point. So
but I think you're right about the other side, right? Like I think the temptation preferences would get you the front loading of spending once the money has arrived. Because yeah, you would say, oh wow, money's here. I don't worry about saving. Let's just do it all now. So I think what that model would generate is the front loading. The first 30 days would look really good, but I had thought that it possibly wouldn't capture the lack of anticipated spending.
No, that's a good point. If we just think of increasing the delta, that'll explain the hump that you're seeing here, but that won't explain the no inaction. Yeah. No, that's fine. That's fine.
Yeah. But it's a good point. And I think, we didn't do this, but I think we could do more to sort of try out some different kinds of models. I will show you one thing that we do. We compare this to a model with heterogeneous discount factors. So some households just have very low discount factors and some have high. That gets us some of the way to explaining the data, but not all the way. I'll say what I mean by that in more detail soon.
Got it.
Okay, so let me start with the data. There's lots to explore here, so I'll try and be fast and focus on the things that we think are interesting. So it's a big administrative data set from a large US financial institution. It's essentially a bank in the US. This covers a huge number of households, 17 million, and we could be using data for almost 10 years. We're not going to be able to do that. It's too big, so we have to cut it down a little bit, but that's the size of this thing. We have de-identified bank transactions. So all of your regular income, all of your outflows, so all of your spending of various kinds. We see tax refunds in particular and bonus checks in particular. On spending, we have to do some work to categorize the spending data, and we're just going to line it up with what IRS does for allocating different types of firms to different kinds of spending codes. There's details there that I won't go into. But finally, we see liquid assets, and this is the question from just before. So this is what exactly we see: checking accounts, savings accounts, credit cards, money market mutual funds, brokerage accounts, and certificates of deposit. Now, everything from money market mutual funds onwards, this is slightly less liquid than the other stuff because sometimes there's some small fees to withdrawing your money and there may be a day or two delay, so you can't access it immediately. But it's not illiquid in the same sense that a house is a liquid or a car is a liquid. So we're just going to lump it in and say, look, these are all our liquid assets. I'll show you in a second comparing this to other data. Okay, we have to do some sample restrictions to actually make use of accounts that are likely to be active accounts, because for all we know, some of these people never use the actual bank account that we see. So we're going to first aggregate up any accounts where we see two people on the account, like a husband and a wife. We'll just aggregate that into one account. Secondly, we're only going to include people who are working age because we don't want to get things mixed up with what's happening with pension accounts, whether that's an inflow of income or are you withdrawing from an asset, makes things complicated, so we'll set them aside. And then finally, to make sure these are active accounts, we have to see at least 5 outflows per month. So you're actually doing some spending. Otherwise, we might be worried that this is not your main account, and in fact, your main account is at some other financial institution. Okay, so there's some summary statistics here, but I won't go into lots of details. Then we're going to look at these different kinds of anticipated income receipts. So we'll focus mostly on tax refunds. And the reason we do this is as follows. So in the US, around 80% of people who file a tax return end up receiving some kind of refund. When you file a tax return, the uncertainty over the amount of the return is basically resolved at the day that you file. So you go onto a tax software website, throw in all your details, it says this is going to be your refund. And unless something very unexpected happens, that is going to be your refund. It can be the case that things go wrong, but it's fairly uncommon. So around 90% of refunds are processed within 21 days, meaning it's a fairly short window from filing a tax return to actually receiving the tax return. And most people are going to get it in that time. So it does mean it's not as if it's like a lottery, like you buy a ticket and then one day you find out the money shows up. It's you know it's coming, and you know it's coming fairly soon. You just don't know exactly when. Because this thing is a really large sample, we're going to do a couple of restrictions. First, we're only going to focus on the households who received one refund in a year. In the US, you can get refunds from your federal refund, but also from the state or the city that you live in. But that does vary across the country. So we'll only focus on the people who get one refund. It's about 70% of the population. And we're only going to take data from 2014 and 2015. It's just too large otherwise. But even with those restrictions in place, still have 1.7 million households, and we still get almost 1 billion observations. So this is a huge amount of data regardless. On the right, I'm showing you some summary statistics. Panel A is all of those account holders, the 17 million people that we started with. Panel B is the subset that we're working with. And all I want to do is just show you that the income looks fairly similar across the distribution of these households. So it's not like we're selecting on richer households or anything like that. Assets looks fairly similar as well. But just keep in mind, out of interest, the tax refund that these people are getting on average is fairly large. So at the median income household, the tax refund is something like 1/3 of their monthly income. So it's not an insignificant amount that they're getting paid. Okay, the data that we see in terms of outflows covers quite a few different categories. So they're all listed here in this little graph. So you can see, for example, that quite a lot of the outflows out of an account go into cash withdrawals. That's the first category. Things like paper checks, which are inexplicably still common in the US. And finally, unobserved credit payments. This is like payments on a credit card that does not belong to the financial institution that we have. So all three of these things, we can't actually tell what's being spent. So, we can't tell the category of spending. We don't know if this is a durable or a non-durable or a service good. Whereas the credit card spending, which might be going towards durables, illiquid debt payments, non-durables, services, and so on, that we can see directly. This unobserved stuff is about 1/3 of total outflows. And so, look, if you're worried about what it might be, we could just throw it away, and we do some robustness checks where that's exactly what we do. It's not going to affect the shapes of our results, these kind of kinky consumption curves. It will affect the magnitude though, because you've thrown away 1/3 of expenditure. So for our main exercises, what we're going to do is impute what we think these spending categories are. So we roughly allocate, cash and paper checks and so on, roughly allocate them across non-durables, durables, services and so on. Most of this is going to go towards non-durables because that's the majority of spending, and a small amount will go to durables and other types of payments. But I can show you the comparison of the imputed versus non-imputed if you are interested later. So just comparing this data to outside data, nationally representative surveys of various kinds, the top table is going to compare spending across categories. The very top row is the consumer expenditure survey, and our survey data is the second row. You can see that total spending looks fairly close to representative spending. Non-durable spending is fairly close to total representative non-durable spending. Durable spending, we massively undercount. I think partly that's because a lot of the spending goes on, it doesn't come off your credit card, but it's, you've set up like an installment plan, and so we don't see that at the financial institution. So we're not going to have lots to say about durables. Services we undercount is because in the US, a lot of services are paid for with cash. Food services like restaurants and groceries, we get fairly close to matching those in the aggregate data. Down the bottom, I'm comparing income and different kinds of liquid assets. Now, this question about how representative of this is, of liquid assets is this. In one sense, it's fairly representative. If you look at checking accounts in the middle there, even let's say in the median, look at the either the Survey of Consumer Finances or the Survey of Consumer Protection, I think it's called, versus our data. It sits somewhere between those two. So we think checking accounts are fairly well represented in our data, but total liquid balances are not. So in the final column, you can see that our total liquid balances are only about half of total liquid balances in the Survey of Consumer Finances at the median. So we're certainly undercounting total liquid balances, but we think we're okay with checking accounts. This is going to be a problem that plagues anyone with this kind of data, though, so we just have to sort of live with it. Okay, so this is the data. Now, what are we going to do with it? Actually, something very simple. So we're going to do a regression specification that makes use of a kind of distributed lags setup. So on the left, we're going to have some spending category, let's say non-durable spending. On the right, we're going to have household level fixed effects and day fixed effects. Now, these day fixed effects are going to pick up things like, oh, everyone goes out on a Saturday and spends a whole bunch of money. And everyone does that. Or, you know, this is Christmas Eve and everyone's spending a lot on Christmas Eve. So it will wipe out those, you know, common spending categories. And then the term and the summation, this is going to be regressing your spending category today, your spending outcome today on receipts that are expected in the future, receipts that you're receiving today, and in receipts that you've already received someday in the past. And these coefficients are going to trace out the marginal propensities to consume over time, and then we just sum them, cumulatively sum them to get the cumulative marginal propensity to consume. And that's what I'm going to be showing you in a second. Oh yes, question.
Thanks, James. So, I mean, basically, I mean, this receipt here is, suppose the guy, you know, pay with the credit card. He paid with the credit card. I mean, the receipt is just 30 days. I mean, how? I mean, which day do you enter these expenses? Is the day that he incurred, or the day that he's gonna pay the credit card balance?
Sorry, super good question. Yep, sorry. Okay, going back to here. So all of these categories on this figure here, like the durables, the non-durables, the services, these are what we pick up from credit card spending, and it's on the day that you spent it. We're not going to include in spending repayments of the credit card, although that is something that money goes towards, but we're not going to include that in our, for example, our measure of non-durables. So you spend today, you went to the restaurant today, and I see your receipt from that restaurant for today. That's what we're picking up. I'm not picking up the fact that 30 days later you actually repay the credit card. I'm not going to use that here.
No, because I mean the credit card also, I mean, people roll over those things up.
No, that's true. They do. There's some really confusing aspects of credit card use in these kind of data sets. So, for example, if you look and you try and just measure what's the median credit card balance, it's 0 in these data sets, and it's sort of confusing. Why? Because it's clear that people should be like holding balances at least some of the time. But it seems like people are really careful to run down their balance to 0, let's say right before the end of a month, to avoid some kind of interest payment or penalty payment.
No, because I also was concerned, for example, I mean, the credit card also is a way that you can, if you spend today because you know that you're going to receive something, yes, an extra income in the future. So I don't know if it will create some problems on your story.
Okay, so you're worried that.
Yes, I use the credit card today because I know they're gonna have a payment increase next month.
Yeah.
So I have since I had 30 days to pay. So
I mean, I'm going to have that in here. So, for example, non-durable spending, that middle category, which is 25% of spending, that is what we're picking up on. Oh well, on credit cards or debit cards, but it's the combination of the two. So for the people that say, "Hey, I know this money is coming. I don't have the money today, but I have a credit card, and I'm going to spend today." That's in our data. That's exactly what we're picking up. Yeah. It's sorry that wasn't clear before, but that's exactly what we're doing. So so this stuff on the left is going to be exactly these kinds of issues. Credit card spending for the most part, sometimes debit card spending, but it's the US, so most of it is credit cards. And we've got these fixed effects and we've got these distributed lags. So are you responding to coming payments, current payments, or past payments? We're going to interpret these coefficients, delta J, as marginal propensities to consume, although it's a little bit of an abusive notation because, of course, these are really just spending. We don't know that you've actually consumed the goods right away. So we're acknowledging that, and then we're going to move on. So let me very first, I'm going to show you what happens when money comes into a person's account. So I'm going to show you kind of the whole balance sheet, whole liquid balance sheet for this household. But then after that, I'm just going to focus on spending. So first, the money is going to arrive in your account on day 0. So this is the day the refund arrives. This is averages across everyone from those regressions. In advance of that receipt at day 0, all of the days, -30 up to 0, you're just not doing anything. You're not spending, you're not moving money around across different accounts, you're not running down credit card payments or anything like that. You're basically just insensitive to the fact that this money is going to show up around 30 days later. On day 0, a bunch of money goes into your bank account, and you can see in panel A, it goes nearly to 100% or nearly to a fraction of 1 of the total spend. Doesn't go all the way because, in fact, on average, people start spending the day the money arrives in their account. So, many people have online banking and so on, so they know that some money has showed up and they start spending immediately. So panel B, you can see that on day 0, there's already like nearly a 10% spending response on that very first day. Panel B is total expenditure. So that does include non-durables, durables, services, it's everything. Later on, we're going to focus more on non-durables, but this is total expenditure. In that total expenditure category, again, no advanced spending, lots of spending in the first 30 days, and then very little spending in the months and days that follow. So there's this significant front loading of spending with respect to the date of receipt. Okay, panel C is movements into your non-transaction account. So think of this as not your checking account, but maybe more like your savings account. Panel D is non-scheduled credit card payments. So people do make small transfers to credit card balances. It's less than 10% of the total receipt of the refund, but it's something. People do move money into deposit accounts, so more like long-term deposit accounts, and people do move a very small amount of extra money into illiquid debt payments. So they do use a little bit of this extra funds to pay off mortgages, but it's very, very small. So this is what's happening across your balance sheet. But for the rest of this, I'm going to focus on non-durable spending, partly because this is the most commonly used measure of spending throughout the literature. It's just the sort of data that people most often have access to. But it's also closest to what we have in mind with, for example, the permanent income hypothesis model. So here the spending responses are smaller. It's not all spending. We've thrown away durables and so on. So this kind of makes sense. Again, no anticipated spend, significant front loading of spending, very little spending thereafter. Comparing to the literature, which has also estimated these kinds of things, a lot of people do something like a 90-day spending response, after 1 quarter, because that kind of lines up with our macro models. In those papers, people estimate anything from about a 10% MPC up to about a 35% MPC. At 90 days, we have something like 25%, so it's right in the middle of those estimates from the literature. So we think we've got a reasonable estimate here. But keeping in mind, this is all averages at this point. Now we want to turn to what happens across the liquid asset distribution. And so this table here is just showing you deciles of the liquid asset distribution. I'm going to scale everything by income though, because we want to keep in mind that we only care about liquidity to the extent it might be helpful for smoothing your income as it fluctuates. So for example, at the bottom of the liquidity distribution, households only have something like a 1 week worth of income in their checking and savings accounts. Whereas at the top of the liquid wealth distribution, people have something like 5 months worth of income, nearly half a year worth of income. So there's quite a lot of variation in how much money people have available to them in case they needed to smooth their consumption. But one thing you might be wondering is, okay, if I rerun regressions across these liquid asset things, it might be that I find differences simply because people receive different tax refund amounts. And perhaps there's some kind of like size dependence in tax refund responses to tax refunds. On the bottom, though, I'm showing you that, in fact, the average tax refund doesn't vary all that much across the liquid assets distribution. So it doesn't matter whether you're kind of low liquid assets or high liquid assets, the tax refund sits at around $2,000. Now, I don't have a strong, I can't really prove why this is likely to be the case, but we think it's possibly because in the US, many people take what's called a standard deduction for their tax refund, and that's just like a fixed amount. And many people take that. I can't remember the fraction, but it's something like 60 or 70% of all taxpayers. I think that's what's going on, but I don't really have a way to prove that. But anyway, it makes us less concerned that our spending responses conditional on liquidity are going to be just driven by size dependence in the income receipt. So here's what this looks like across the liquid asset distribution. I'm going to group households by the quintile of their liquid assets measured in the 9 months prior to the tax refund. So their liquid asset balances are not getting mixed up with the actual change in their liquid asset balance as the money comes in. This is all prior to the tax refund. So at the bottom of the liquid assets distribution, you're going to see something very similar to the top of the liquid assets distribution. Very little anticipated spending up until the day the money comes in, and then a lot of spending in that first 30 days, and then much smaller amounts of spending in the days that follow. The thing that does differ across the liquid assets distribution is that low wealth households have much higher average spending, after the income comes in. Their MPCs sit at something like 30%, whereas high wealth households, these ones down in panel E, these guys, their MPCs sit at something like 10%. So you can think of the poorest households are about 3 times as sensitive as the richest households. Yeah, Girish.
So James, 2 questions. One, I mean, this point was raised earlier as well. So if you're mismeasuring, or if there are measurement errors because you're seeing one bank, and individuals can hold multiple accounts in different banks, then my hunch is that what you're showing here will in fact continue to be true, and the error would basically imply that the guys that you're are categorizing as rich or liquid are probably, some of them are not truly those rich and liquid.
No, I actually think it's the other way. I think the guys here who I'm categorizing as rich are actually even richer than we say, because these are the guys most likely to have bank accounts elsewhere for various reasons, right? Like for all sorts of money management sort of reasons.
Right.
And we saw that in the data. These guys, we're undercounting their liquid wealth by quite a lot. So if anything, these guys are even richer than we say. But I don't think the thing that matters here is I don't think the ranking of their wealth is really going to change all that much. It's just going to change the absolute level.
Right. No, my point was actually, even if you do have an error, then whatever differences you are measuring are despite that error, not because of that error.
Right.
So in fact, if you have error, that's fine. What I wanted to understand was as follows. The 2 point is, one is, what if so if it's random, that I'm an individual, I get my tax returns, and I'm keeping my tax return account as someone that's not really that big, and I have those bigger accounts somewhere else. If this is systematic, then you'd be overestimating the impact. If it's not, then it's it'll be inefficient, but it won't be the estimates won't be biased.
So your worry, for example, is that the top quintile guys actually are spending in the pre-period, but we're just not seeing it in this account. It's actually at some other account.
That's my worry. And this is only if it's systematic. If it's not systematic, and if that error is random, then the only thing you'll be doing is inefficient estimates, but they won't be biased. But this is just my thought. The second query would be, in Australia, for example, people can park their funds, in fact, quite a lot of funds in their mortgage accounts. They're fairly
you can't do that in the US. That's quite peculiar. Yeah, that's quite peculiar to Australia, the UK, and New Zealand. But as far as I know, and I'm in that literature, it doesn't exist in the US.
Okay, cool. Yeah, so
but it's a good point.
Nothing.
I mean, they can. Okay, to be fair, they can prepay, and you see a little bit of that here. So that's what that bottom right figure is sort of capturing that. The real difficulty we have here is that what is unusual about the US is that when you take a mortgage out, you may take it out with your bank. Your bank may then sell that mortgage on to someone else, and then all of your mortgage servicing payments don't go through the bank, and we wouldn't necessarily see that. So this panel F, I think, is actually understating payments to mortgages because we're just not seeing the money go out to a different kind of institution. So but we're not focusing on it all that much. So
that's fine.
But yeah, I take your point. There's really nothing we can do. We can't see the other financial accounts, so we just have to hope, like you said, that it's not systematic across the wealth distribution. Yeah, it's a really good point. Tushar.
Yep. Sorry, that's not my field, but I was wondering to what extent could it be explained by these households waiting to make a lumpy durable investment, like buying a car, and then the non-durable expenses that you find just go hand in hand with that durable purchase.
That's a fair point, but in a standard model with lumpy durables, you still see consumption smoothing on the non-durable good. So it's true, it does have some effect on the non-durable good, but it's not going to look like this. I've sort of played with those models before. It's not going to have this kind of shape.
Thank you.
Yeah. That's a fair point. So, okay, so we think these, okay, to the extent that we sort of believe them, that there's not these systematic problems that mean that the results are kind of understated or overstated, we think that these models are, this result, sorry, is inconsistent with a standard model of borrowing constraints. High wealth households should be consumption smoothing, if anyone is, and yet they're not. It's also inconsistent with models of, for example, rational inattention, because households, once they learn about a payment, should be willing to spend out of it, and yet they don't. And as I kind of mentioned to Gresh earlier, I think, but I'd have to work this out for sure, that it's inconsistent with models of, for example, temptation, because again, once I know that a money amount is coming, I should be willing to start spending out of it right away. If anything, I should be more willing rather than less willing. I won't go through them, but there's a ton of robustness checks we do. So we do this again without imputing these non-observed expenditures. We do this by looking at different kinds of spending categories, so durables, non-durables, services, groceries, and so on, and it all looks kind of the same. We, in case you're worried that by throwing away the people who receive multiple tax refunds, something funny is happening there, we redo that experiment and again find similar results. In terms of the information, you might be a little worried that maybe households just don't really know that their money is coming. Maybe they're all kind of naive. We actually have a subset of households where we can see the tax filing date. So we know that those households know that their money is coming because we know when they found out about the tax refund. Even conditioning on tax filing dates, we still see the same kind of patterns. You might be worried that, for example, once we stratify by liquid assets, maybe it's kind of grouping on households of different income levels. Maybe all of the low wealth households are also low income households, and that makes them different in some way. If we stratify first by income and then by liquid assets within income groups, we find exactly the same results. So we don't think that's what's going on. And then finally, we do these other types of spending as well, not just tax refunds. You might be worried that tax refunds are special in some way. We do bonus checks. Bonus checks are generally wealthier households, so it is a selected sample, but they are also infrequent. You tend to only get a bonus check once a year. Same kinds of patterns, just smaller NPCs, which you might expect. And then finally, we also do this with regular paychecks. Now, regular paychecks are a little bit weird because, they happen all the time, and, maybe some types of spending are kind of like on purpose designed to fall right after a paycheck day. So we try and do this for categories that we think are more like spontaneous spending, like going to restaurants and so on, that we see the same kind of thing. In fact, the spending responses to regular paychecks look very similar to the spending responses to refunds, tax refunds, especially in the week or two either side of an income receipt. So yeah, I'm happy to show you any of these, but these are just trying to show you that these results stand up under different, under different circumstances. Okay, so if there are no questions, then I'll move on to the model, which is kind of my contribution to this this paper really. So we wanted to try and get at a model that's going to capture this kind of kinky consumption behavior. It turns out that's actually quite hard to do. Standard models of liquid assets are not really going to capture this very well. Other types of models don't capture it very well, but behavioral models sometimes can. And we're going to focus on one. This is a mental accounts model. So just keep in mind, this is the model of my mother who has envelopes in the cupboard. She doesn't like touching the envelopes. So the way we're going to set this up is quite simple. We're going to have a utility function up the top here, where you've got a standard component to your utility function. Think of this as log utility or CRA utility. But you also have this penalty term, the minus D term, and you're going to be penalized if your consumption ever goes above your current income. So there will be households who are sitting there with some assets available to them, but if they ever start dipping into their assets, that means dipping into these envelopes in the cupboard, they'll be internally penalized for doing so. And the way we set up the penalty function is like this. The penalty is 0 as long as consumption is less than income. And the penalty is this psi parameter times this difference in utility from consuming your normal amount minus consuming the income that you would have consumed. So this is going to generate like this. It's going to generate a kink in the utility function. So the gray line is a standard utility function. Let's say log utility. This is where no mental accounts are in operation. So along the consumption axis, your utility is smoothly increasing and concave. The black line is an extreme example where we put a very heavy parameter on this, an extreme heavy parameter on this penalty for dipping into your current income, dipping into your current assets. And so what happens is you have the same utility function all the way up until the point where your consumption would be equal to your income. But after your consumption is higher than your income, you're dipping into your accounts, which you don't like to do, and your utility is going to be dramatically lower than it would be otherwise. In this particular case, essentially the marginal utility of consumption goes to zero for any dollar spent above your current income. Of course, we want something that's in between these two extreme cases, but this is just to highlight what the utility function is doing. Now, the difficulty here is the kink. Anything we're going to do with a kink can be problematic, so we do have to make some sort of assumptions to get around it. I'll mention those in 1 second. So let's put those preferences into a standard model. So absent the mental accounts, this would look like a permanent income hypothesis model. I could show you all of the permanent income hypothesis results in this setup if you were interested. But what I'm going to do is take a standard CRRA utility. So gamma is the intertemporal elasticity of substitution. We also have this mental accounts penalty, the term D. And then we have a standard budget constraint. You're consuming plus putting away some savings. That's AT plus 1. You're receiving some income, YT, and you've got some existing savings that you earn a return on. And then your consumption default level is just the income. So you're always comparing things to your current income. And for this version of the model, we'll assume that income is a deterministic stream of receipts that you know about in advance. And there's no borrowing constraints and there's no liquidity issues. So this is not a household that's worried about liquidity. Think of this as like a rich household, someone at the end of that liquidity distribution. Okay, the kink is our problem here. So to do most of what I'm going to do, I have to work with interior solutions. So suppose we're not exactly at the kink. We're somewhere away from the kink, but on either side is fine. So away from the kink either side, we can write down an Euler equation. And if I delete those two terms, the 1 minus psi terms on either side, it's back to a standard Euler equation. It's the same as you get in normal, macro kind of models. But the two terms that are different is the first term here on the 1 minus psi with the indicator function, and on the right, the 1 minus psi with the indicator function in the second period. And these two things represent both a static distortion to my behavior and a dynamic distortion to my behavior. And it can work like this. So statically, from today's perspective, suppose I get some more income. Well, I don't want to consume out of my current assets. So I'm discouraged from doing so because of this mental penalty from doing that. And so it's going to encourage me to consume less and drag down my consumption in order to maintain marginal utility. But as I drag down my consumption, that's going to lead to more savings, and more savings will then be available to me in the future. And if I have more savings available in the future, then I'm more likely to consume more than my income in the future, which I don't want to do. So there's this sense in which these mental accounts can generate both current or static distortions, but also dynamic distortions through time. And it's the interplay between these two that's going to generate this kinky behavior in the marginal propensity to consume. So don't worry too much about the maths, but I'm going to write down the solution to this problem. This is it's an implicit solution, but it is the solution to this problem for consumption. Again, up the top, we have the static distortion, and down the bottom, we have these dynamic distortions. So all of the big term on the right is just your lifetime resources. Okay, so this is the consumption function. Now, I'm not going to show you the mathematical proof, but I can show you a nice kind of intuitive proof. So imagine that you had a household who was consuming exactly equal to their income across their life cycle, across all periods T. And now what we're going to do is announce at date 0 that you're set to receive some income at date H. So it's like a tax refund. You're going along, you're happy with your consumption, but then you get told that there's a tax refund coming to you. So you know about this, you know that it's coming at date H. And what that's going to do is you would like, if you were a normal consumer, to raise your consumption slightly in all periods. You'd like to smooth out consumption, so you want higher consumption at all dates. And the way you'll do this is by borrowing in the early period. In the period you receive the income, you repay some of that borrowing and then save some of the money as well. And then you spread it out by consuming out of that savings in the future. The difficulty is for a mental accounts consumer, this means that in the period before the income is received, you're now consuming more than your income. And you don't like to do that because of the penalty. In the day that you do receive the income, you're consuming less than your total income, and that's okay. So you're not going to face the penalty. But finally, in all the periods after you receive the income, you're also consuming more than you were, and you don't like to do that either. So there's a penalty at those periods. This is what's going to get you that kink in the marginal propensity to consume. So maths, ignore it, but down the bottom, this is the closed form analytical solution for the marginal propensity to consume. And crucially, it depends on this penalty parameter, how much you dislike consuming out of those envelopes that you've put into your cupboard. And crucially, it depends on which day you're currently in relative to the day of income receipt. So on the days of income receipt, you're okay with spending, and you're going to have these big spending responses. But in all other days, you're not going to be happy about that. We can take that function and write down extreme cases here. So the simplest extreme case is simply to set the penalty equal to the maximum value of 1. And in that case, we basically get hand-to-mouth behavior. So households are going to spend only on the day the money comes in, but not on any other day. Then, in the other extreme, we're going to turn off mental accounts. And then you have an MPC that looks like this. It looks a bit confusing at the moment, but we can simplify it. So suppose you have log utility, get rid of the discounting and things like that. Then your MPC looks like the standard marginal propensity to consume as a function of the discount factor. Now imagine this is a monthly model. Discount factor beta is going to be something like 0.999 or 0.995. In that case, your MPC is very, very small in every period. And so here's your two extremes. Hand-to-mouth behavior on one end and very small smoothing consumption behavior on the other end. So let me show you that in panel A. In panel A, what I'm showing you is, I'm just going to do it at the monthly frequency. So I'm going to show you MPCs in the month before you receive a lump sum payment, the month of the payment, and 1 month after the payment. The green line is taken from the data for the richest households. So they're fairly small MPCs overall, but they do have this kinky consumption response. And then the blue line is from a simple back of the envelope calculation using those MPCs I just derived. So you can see you mostly generate the small anticipated spending response, the large spending response on the month of receipt, and the very small spending response in the month that follows. But contrast that with the standard model, the model without mental accounts, that's the dashed line in red, and you get smooth MPCs the whole way through your spending receipts. So our model is going to generate this kind of lumpy behavior, whereas the standard model is not, the red line model is not. One small thing I want to point out as well is there was this point made by a recent paper by Bao and others that consumer spending in response to income gains versus income losses appears to be quite asymmetric. So households that gain a lot of income are going to do this kinky spending a lot out of the money as it comes in. But households who see an income loss coming, for example, if they're forced to make a tax payment, they don't respond to that at all. In fact, their consumption response is almost zero. Instead, what they do is they move assets around. Our model generates that asymmetry. So we don't have much to say about it in the data, but we can see that in the simple model. So, very excess consumption sensitivity to income receipts, but consumption smoothing with respect to income losses. So it's kind of an interesting extra feature of the model. So that's our simple model. And I think I have 10 to 15 or a few more minutes to get through the more complicated model. The simple model, remember, does not capture liquidity issues because this is a standard model with no borrowing constraints, no income uncertainty. So we have to treat this as like a household who's kind of rich. So you might say, great, success on capturing rich households, but we need to see more about the illiquid households as well. I want to know how much of the model, how much of the empirical results are explained by liquidity versus potentially this mental accounts mechanism, and that's what we're going to do next. So this is a quantitative heterogeneous agent life cycle model that we're going to use to study the same consumption responses. Some features of the model are standard. We'll assume that these are working life households. There's no retirement in this model. During their working life, households will face earnings and employment risk. They'll have access to a simple liquid asset with a simple borrowing constraint. So some of these households will become borrowing constrained, and that will be a problem for their consumption smoothing behavior. The novel features of the model are that we'll capture this at a monthly frequency. So it's a very high frequency model compared to these models. Usually these are annual or more. We're going to have to incorporate anticipated income receipts, which is not normally done. So I'll show you how we do that. And then finally, we'll embed the mental accounts utility function. That's not so hard, but it is new. So the idiosyncratic state variables for this household are the age of the household, denoted in months, the liquid assets of the household, A, the productivity of the household, so how much do they earn given that they're in a current job, whether or not the household is employed, E, and the date that they're set to receive some income inflow in the future, H. Household labor income, it depends on whether you're employed or not, depends on your productivity, and I'll also include a life cycle earnings component, your standard kind of hub-shaped life cycle process. Nothing fancy, this is all standard from this kind of literature. The income receipts, we have to make some assumption here. We're going to make a strong assumption that these are from the household's perspective, zero probability events. So the households are sort of going along through their life, never expecting to get one of these anticipated income receipts. But one day I announce to the household that, hey, you've got one of these things coming. Once I make the announcement, the household knows how many more periods before the receipt will show up, and they know this with certainty. There'll be, potentially several months before the money shows up. Then the money shows up, and suddenly they have the inflow. And then after that, the household believes that they'll never see one of these inflows ever again. So we could incorporate uncertainty. We could incorporate repeat events. We don't. We just keep it simple and suppose these are one-off, zero probability events from the household's perspective. The way that we'll pay the households is proportional to their income. So think of this as like a tax refund. If you earned, $100,000 this year, it's some fraction of that money that's coming back to you. This is nice because it will scale with income across the distribution of income and assets for households. Okay, I won't go into the heaps detail, but this is the way you write it down. Here's the value function problem for this household. Standard utility function minus the mental accounts utility function. Discounted future expected values because there's uncertainty coming from this income process. Budget constraint looks the same as before. And then there's some extra features. Don't have to go into too much detail. The only small thing we're going to add is I'm going to allow for heterogeneity in mental accounts. So I don't know, maybe you guys want to ask yourselves at the next staff meeting, who's got envelopes in their cupboard with little writing on them? So I do, but some of my friends don't. So we recognize that not everyone is going to be a mental accounts consumer. So we want to allow for that heterogeneity. So we'll have a parameter if you are a mental accounts household and a parameter set to 0 if you are not a mental accounts household. Finally, we have some probability that you are or are not a mental accounts household. And a small thing, we need a terminal condition. It's kind of standard, follows Corintius and Peri Levier well, but nothing fancy there. Okay, internal calibration, I'll skip that. We're gonna, once we've done an internal calibration, picking some parameters to match what's in the data, what's in the existing literature, then we estimate the model via simulated method of moments. And what we're going to get the model to do is try and match two sets of moments, statistical moments, simultaneously. The first set on the left here with the MPCs up the top, this is matching the marginal propensities to consume across the distribution of liquid assets. So we want to capture the fact that low wealth households have very high MPCs, high wealth households have very low MPCs, but that it's smoothly declining through time, across wealth. And then the second set of statistics are liquid wealth balances across the life cycle. So because this is a life cycle model, households are going to accumulate wealth over time, but we want that to happen simultaneously with having these high MPCs for the high wealth guys, and try and match both of these simultaneously. I've got my my parameters down the bottom. The pi I just tells us that around 13% of these households need to be mental accounts households, but conditional on being mental accounts households, they have a fairly high penalty from consuming out of their liquid wealth. So on the left in blue is the data, that's the circles, and the solid blue line is what the model generates. This is MPCs across the distribution of liquid assets, and we do a really good job at matching this. So we can capture the fact that low wealth households have high MPCs, high wealth households have moderate MPCs, and it's kind of a smooth line through the middle. On the right in blue, we have the liquid asset distribution, the average median liquid assets by age. And you can see, as in the data, households slowly accumulate wealth over their life cycle. Now, what's not targeted by the estimation is this red and green line on the left. So what these two lines are picking up is these are in green down the bottom. This is the anticipated MPC. How much do you spend out of money that's coming? And the red line is how much do you spend out of money that you received in the past. So the red line actually matches the data very well, even though we didn't target it. So we do capture front loading of expenditure with respect to income receipt extremely well. The green line is a little bit off. We do have a low spending response to anticipated income receipts, but it's not exactly 0. So we're not capturing everything, but we're doing as much as we can with the model. Let me show you why I think this is okay, though. Okay, I won't go into this too much detail. I want to show you this one. This one and then the next one. Okay, so what we're going to do instead is say, well, let's check whether that standard model could have captured these kind of patterns in the data. Maybe it can, maybe it can't. So let's start with a model that just doesn't have mental accounts, but is otherwise standard. Okay, the blue circles are again the data for for MPCs across the liquid wealth distribution and the asset accumulation across age. The solid blue line is a version of the model that simultaneously tries to match the MPCs and the liquid wealth accumulation. That model fails to do both. It understates MPCs, especially for low wealth households, and it understates liquid wealth accumulation, especially for older households. The other two lines in red and in green, these are models where we only ask the model to match either the MPCs across liquid wealth or life cycle wealth accumulation. These models do fine on the statistics they're being asked to match, but they really fail to match the other statistic that we didn't ask them to match. So a standard model cannot capture these features of high average MPCs across the liquid wealth distribution, as well as liquid wealth accumulation as you see it in the data. Let's take a model though that's it's a little bit unfair to ask that previous model to try and match all the stuff without extra parameters. So let's do a version of the model where we're going to allow for heterogeneous discount factors. This is fairly standard. You see this in other papers like Crusoe-Smith and so on. You say one household has a very low discount factor, one household has a very high discount factor, kind of like impatient and patient households, if you like. Otherwise, everything is the same. Again, we're going to target both statistics, the MPCs and the liquid wealth accumulation. And the blue lines in each graph suggest that this model does a reasonable job at capturing both. It can capture the high MPCs that decline with liquid wealth. It can capture some of the wealth accumulation across age. What it cannot do, and it fails to do this quite obviously, it cannot capture the lack of anticipated spending. That's the green line, is much too high relative to the green squares. And it cannot capture the lack of, front loading of expenditure receipt. So you can see that households, especially low wealth households, are spending a lot in the months that follow an income receipt, and that is not what you see in the data. So a standard model can get some of the way to capturing high spending responses and liquid wealth accumulation, but doesn't capture these extra features of the data, this kinky consumption response that you see that I showed you right back at the start. Okay, I have 15 minutes. So are there any, just before I jump into the final experiments, are there any questions about the way the model works or features of the model you'd like to see? Oh yeah, go for it. Rodney, go for it.
Sorry, I assume it's me. You don't say very much at all about returns on wealth. I mean, for the wealthier households, what you notice is that your model does a lot better than it does for the poorer ones. And the wealthier households are going to have a lot of income from their existing wealth. And moreover, the yield on their wealth is likely to be much higher than the yield on the wealth of the very low income households, right? So, so some of that difference between low income and high income may be explained by something that you're not really emphasizing here, which is that R.
That's true. Yeah, so and people have done this. There are models that think about either multiple assets or, for example, you could make that R dependent on your asset level, A. So it's just a maybe like an increasing function of A. And there's all this data out of the Scandinavian nice data sets showing that even for very simple liquid assets, the wealthy make much more as a proportion of their wealth than do the poor. We could incorporate that. I don't know what it would do to the results. I guess it might, it could mean that the wealthy are, even without mental accounts, are perhaps less willing to dip into their liquid assets than the poor. That's true. It might capture that feature. We haven't done it yet, but it's a good.
Yes, less willing, or the difference is less significant to them, right? And given that they have substantial income outside of these payments, that the significance of the tax refund may be just very, very low for them.
Yes, because it might be that they have $100,000 in the bank, and at that size, you're getting $1,000 a month or something. Yeah, that's true. I don't actually think that would be hard to do either. You could certainly just put like a simple function for this R as a function of A and incorporate that as well. We should try it. I haven't done it, but we should try it. It's good.
I mean, it's just that, I mean, in a lot of my teaching in macro, I try to emphasize the fact that the opportunity cost of current consumption is actually the income in the future that you're denied from the saving you might make. And it's not clear that, I mean, I know that's not an essential part of the permanent income hypothesis, but it's not something that is captured well,
No.
I think in the model you have, yeah.
No, that's true. Yeah, no, I fully admit that. It's not captured here, and it could be, and it's not hard. So in principle, we could add it and allow for that.
Yeah.
If anything, probably what that does, if you did include it, is in these figures here, for example, even without mental accounts, you might get a higher, which way around? Oh, probably get a lower anticipated spend for the wealthy households, and probably a higher contemporaneous spend for the wealthy households as well. Yeah.
Like
Maybe that would like reduce the emphasis on mental accounts for sure.
Thanks.
Yeah, Gresh as well.
So I'm probably may not have completely understood the static and the dynamic distortions that you were talking about, but what my understanding is that because you have this mental disutility of consuming more than your income, your model can nicely explain why there's no consumption response before the actual check arrives in my account, and that's pretty neat. And that doesn't happen with deltas, that is, discounting preferences. That's neat. But then it's like a double-edged sword, no? And I think that is the reason why you're seeing those green things that are not exactly zero, because if you have a very high, psi parameter, just correct me if I'm wrong, if you have a very high psi parameter, then obviously you won't have, can you hear me?
Yeah. No, I agree. Everything you're saying is exactly right.
Okay. Yeah, no, exactly.
No, you can see it here. Oh, I mean, I can see it. I can show it here. Like, here's the extreme case. Set the psi all the way to 1, and then you go all the way to hand-to-mouth behavior, where it's just 0 responses before, sharp response in the day of, and then 0 again. But there's kind of a trade-off, because with only one parameter, it's really difficult to simultaneously get the anticipated response all the way to 0 and to get the contemporaneous response to whatever number you need it to be, 10% or 15% or whatever.
Right.
So I think that's
otherwise you'll have a very high MPC on the day of the check, which you don't.
Actually, that's a really good point, and I skipped it because I thought it was running out of time. Let me show you it here. So this version of the model, I'm going to show you the data in blue. I'm going to show you the benchmark calibration in solid blue. Now, the one you want to do is this green line. So what I'm going to do here is I'm going to make everyone everyone a mental accounts guy. So I'll get rid of this heterogeneity. Now, what that means is everyone has this very high 80% penalty parameter, and you can see it right here. Look at panel B and panel C. The MPCs skyrocket; they jump right up across the whole wealth distribution. But what you get in return down the panel A is the green line goes all the way to 0. So you're exactly right. With a very high parameter, I can get the 0 anticipated response, but then I'm going to overstate the contemporaneous response.
That's
so
right.
Yeah, I sort of see this as like a first. If this is considered like a successful line of research, this is the first step. We do a one parameter model, see what it does, and we get some of the way. But of course, there's more to be done. You have to think about: do you need more parameters? Do you need more flexibility there?
No, very interesting. Yeah.
But yeah, you're absolutely right. Good intuition. Yeah. So let me do one final thing. So we're going to do some. It's simple. In fact, this is so simple. I thought about killing it from the paper, but the referees sort of liked it, so we kept it anyway. But so what we're going to do is take the model and we're going to think about fiscal stimulus payments. And this has kind of got renewed interest, especially because of the COVID stimulus payments in the US during 2020 and 2021. So in that case, those COVID stimulus checks were a form of untargeted spending. You just give every household a blank, well, it's not a blank check, but a check of a fixed amount. Doesn't matter what your income is, you're going to get that money. In contrast, there's some types of fiscal stimulus that are targeted. So for example, simultaneously during COVID, they did these boosts to unemployment payments. So they said, if you are unemployed, we're just going to up your unemployment payment by $600 a week. Now that's like giving money only to the very lowest income people in the population. So it's very targeted. Another way of targeting rather than by income would be by assets. So you could say, okay, we're only going to give money if you don't have sufficient money in your bank account. I couldn't find an example of this as like a stimulus policy, but for sure things like food stamps and assistance for needy families, these do have asset tests as part of them. And so at least some government policies have this form of asset testing, and we could target things that way. We might think this is useful because a lot of this is about liquid assets, and so targeting by assets could be a useful way of getting at the high MPC consumers. So I'm going to do basically the size of the stimulus check that people got during COVID, about $1,200 to every household. That's my untargeted spending. If instead I take the $1,200 and I reallocate it to the bottom 20% of households by income or by assets, Instead, they're going to get $6,000. So these are our three comparisons, targeted stimulus versus untargeted stimulus. And finally, I'm just going to compare the mental accounts model to the heterogeneous discount factor model, since that's the one, the alternative model that best fits the data, but fails on a few of these key metrics. So here's what the model kind of looks like on the left. This is mental accounts. You can see that untargeted spending actually looks very similar to targeted spending, especially by assets. So we don't really get much of a gain to redirecting your money to the bottom households by assets. So there's sort of not too much point in doing that. But that contrasts with a more standard model with heterogeneous discount factors. In that model, if you target spending to the low assets households, you get a much bigger boost in aggregate consumption response than you would otherwise. So your standard models, you might go ahead and say, no, targeting is a good idea because we want to hit these low MPC guys, and you can actually do that effectively. In the mental accounts model, that's much harder to do, largely because you have mental accounts guys all throughout the liquid asset distribution. And targeting is not necessarily a direct way of getting the money to the highest MPC guys. If it was possible to know who the mental accounts people were, I go check every cupboard in the country and I look for the envelopes. Okay, then that will work very well, but obviously that's a very hard policy to roll out. So it's a simple point, but we just wanted to revisit these kinds of fiscal stimulus policies. So just to conclude, and then I'm happy to chat for 5 minutes or so. We took a very rich micro data set to study consumption responses to anticipated income, mostly focusing on tax refunds, but we had some other data as well. Looked at the relationship between household liquidity and spending responses, and we find across that liquid wealth distribution, even very wealthy households are not effectively smoothing consumption. So it's kind of a puzzle for models of liquidity in particular. And so instead, we developed a model of mental accounts as an explanation for this kind of kinky consumption behavior. And we, to some extent, think this rationalizes the pattern of marginal propensities to consume across the liquid wealth distribution. And then as a final little exercise, we say, well, what does this imply for fiscal stimulus policies? And we look at, different kinds of targeted versus untargeted policies as a way of seeing what this does. So yeah, that's everything. Happy to chat for a few minutes, and then I should get off to teaching. Make sure those students learn their macro in one way or another.
Thanks, James. Very interesting paper. Questions? I think you were very clear, James. So there are no questions. Everyone's happy. So if you want to talk about something,
no, it's great. No, but thank you for the comments. There's some really good ones there, and yeah, I might actually include some of that in the redrafting. We're sort of in the final stages now, so hopefully I can get it off the desk and then move on to something new. But yeah,
all the best for that. Yeah, and all the best. And thanks again. Yeah.
Thank you. And I guess lunchtime for you guys, I suppose.
It's nearly lunchtime for us. Yes, in an hour or so. Excellent. Well, thanks again, and we hope to have you in person next time around.
Yeah, for sure. Yeah, looking forward to it. Maybe see some of you at WAMS when it's over.
Yep.
Western Australia. Cool. Thanks everyone.
Excellent.
See you again soon.
Thanks. Take care. Bye.
Thanks, James.
Thank you, James.